Okay, this is Stats260. We're looking at chapter 9. So on the first page of the chapter 9 notes, let's take a little look. We're testing the difference between two means, and we're using a z-test. So that means we have the standard deviation of the populations, both populations. So let's read the example here. Oh, they have this equation. I just wanted to put this on the board because this mu1 minus mu2, that's always going to be equal to 0 for our purposes. So you don't really need that even in the formula. You can go to your formula sheet right now and go and just make that 0. All right, so let's see. A survey found that an average hotel room rate in New Orleans is $88.42. In Phoenix, it's $80.61. Assume the data were obtained from two samples of 50 hotels in each. So N1 was 50 and sub 2 was 50. Population standard deviation of the first one, New Orleans, was $5.62, and Phoenix was $4.83. At a 5% significance level, can we conclude there is no significant difference? So we have the null hypothesis, which is the mean of the first population is the same as the mean of the second population. That's the null. The alternative is that they are different. It didn't say one is higher than the other, just different. So that makes this a two-tailed test. So at a 5% significance level, we look that up, 5% two-tailed test. You follow it all the way down to the bottom, and you see z is equal to 1.960. We're going to call that both positive and negative 1.960. All right, so 1.96 and z is equal to positive 1.96. And so yeah, when you look on your chart, on the top of the chart, just like we have before, we find the standard deviation, or not standard deviation, you say two-tailed test, and then 5% and follow it all the way down, and you'll see the 1.96. So there it is. All right. So that's alpha is 5%. So now we have our pretty picture. They kind of did the work for us. So they put in the 88 point here. Let's do the rest of it though. Here, I'll just rewrite it. 88.42 minus 80.61, and then that's minus 0, so you really don't need the rest of anything else on the top. So we're finding our z-score, and then it's the square root of the variance, really, of the first. So they gave us standard deviation is 5.62. We're going to take that and square it and divide by how many were in the sample. That's 50. And we're going to add that to 4.83 and square that and divide that by 50. And so this all shakes out to be 7.81 over 1.04798, which is 7.4 standard deviations above the mean. All right, well, it had to breach 1.96, and it's way over here, 7.45. So it is definitely in the shaded area. So we are going to reject the null hypothesis since 7.45 is greater than 1.96 by a lot. We summarized there is enough evidence to reject the claim that the means are equal, since there is no significant difference. Hence, there is a significant difference in the rates. So those are actually different. You might say, oh no, it's only $8. It's significantly different at the 5% alpha level. All right. So let's see, it's in the reject, so we reject the null, and this is our conclusion. So we conclude at a 5% level that the prices for hotels are different. All right. So let's look at, that's sort of 9.1 and 9.2. Let's take a look at 9.3. That's going to be the same thing, but what if we don't have the standard deviation of the sample, but rather just the standard deviation, or we don't have the standard deviation of the population, like this one, we have the population standard deviations, so we got to use Z. Well, it's just the same thing for 9.3, it's just with T. If you don't have the standard deviations. Tell you what, I'm gonna make that one the next video.